Hey everyone, welcome to my channel Bend the Rules, where we talk about JavaScript things in depth. Today we're going to see how to read and understand the Ecmascript specification. If you have been using JavaScript for some time, you already know what the specification is. It defines how the language JavaScript is supposed to work, and it's something that covers all the things, all the edge cases related to the language and its features. Now, the first thing that people would ask is, why read the specification? We already have a lot of great books, a lot of good articles which you can refer to. And I think you should absolutely do that when you are learning or understanding things for the first time, right? But the way I understand is that the specification is the source of truth. So all the authors are trying to read the specification, simplify it, maybe put some of their own abstraction on top, and explain it to everyone, right? So sometimes in the process, you will lose some of the details. You will get a very simpler explanation which might not explain everything to you. You might want to see what will happen in case of a edge case. So I think for all those things, the best way to do is, instead of doing a lot of guesswork, the best way is to go to the specification and try to read that particular section. So that's what we're going to try and do today. We'll start with an example and see how that is implemented according to the specification. So now let's look at the actual specification and see what all it contains, because it's like a huge HTML document. It's might be hard to get your way around unless you know which part contains which things. Okay, so I'll just start marking here. So initially it will talk about the different data types and object that it contains. So for example, all the public methods that you have like Object.assign, they are not really defined or explained in this section, but let's say object contains some internal methods which are not shown to JavaScript. So those things are usually explained in this section. Okay, so this contains a general description of the data types and some of their internal operations. Now where it starts getting really interesting is in this next part. I'll just again mark here. So when you see this part called statements and declaration, this will talk about all the if statements, switch cases, and for loops that you use in the language. What happens when you use that, what is the syntax, and how it should be evaluated, or how the thing should run. And similarly, it goes into functions, classes, some of the object operations will be right around here, and same things for numbers and strings. So if you're looking for how the public methods work, this is the best place to get started. They will often refer back from here to maybe some of the internal definitions in the above part. So let's do one thing. Let's go into an if statement and see how that works. So I'll just directly use this link here, but it's actually within the statement section. So if you go in here, you will see that this got highlighted. Okay, so the first part that we'll see with any kind of statement is that it contains a syntax or the grammar first. So this will basically talk about what are you allowed to write in a if statement. How does a if statement look like? So you will see that it has actually two forms here. So there is this one form which is the easier one. It says if expression and then a statement. So basically, if you have a if condition and then just a body, you don't have any else section here. And then it has another definition for if. It's like these are like two possibilities of a if statement. It can be either the one at the bottom or the one at the top. So it says that if expression then a statement, and then again a else with another statement. So this is the part, this is the way if you have like a if and then a else part, so then this grammar is going to apply. So now we have seen the two forms of if statements. Let's look at how the JavaScript engine runs any one of these forms. Also notice that there are these sections called as static semantics, or in the left as SS. These are things that the browser can figure out just looking at the if statement, and this will contain things like syntax errors or some common property of the statements. But for our understanding right now, this is not very important. But we are really interested in most of the cases is in looking at these RS sections or the runtime semantics. So what happens when this statement is running? So if I go into this part, notice that it again has two sections. So it's basically saying that it has these two form of grammars, and if it matches any one of these forms, then this is the algorithm that is going to run, right? Whichever is written below it. So let's look at the simpler one. If expression then some body. So first it says that evaluate the expression. So if you have something like if a less than 10, then write console log, hey, it's 1 or something. So when you say evaluate an expression, it's basically running the string a less than 10 and storing the value in here. So a little note here is that, again, this is a form of abstraction. It doesn't store the value directly. What I mean is it contains, it stores it in this expression reference, and in the next step, it's actually going to do get value of expression reference. So when it does the get value, that's when you get back the actual value which we are thinking of. Let's say a less than 10 will be true or false. So that is what get value returns. Now, your expression in the first part doesn't necessarily have to be a comparison operator, right? What I mean is it doesn't have to be a less than 10. It could have been if hello, right? It could have been just a string, but the if statement needs to convert it to a boolean before moving to the next step. Now this method that you see here called ToBoolean, that is what we call as a abstract operation. So these abstract operations are again defined, I think, yeah, somewhere around here, right? These are somewhat let's just say common methods which are used across the whole specification. And so basically it's if it gets some string or some undefined or any of the primitive types or even object, it will return you either true or either false. That's the purpose of ToBoolean. Now what it says is that, okay, if it has returned false, then return a normal completion. So we'll look at what completion records are, but normal completion is like a type of completion when the user is not exactly returning something, but the browser is returning a type of completion record, sort of for its own record keeping or for its own sanity. So anyway, if the expression value is true, then it goes into this section. So what it says is that if that is true, then evaluate the statement. So if a less than 10, then run the console.log statement. Okay, and whatever value you get from there, just return a completion right around here. So this is a little bit interesting thing, right? If you notice, in this case, when the if condition was false, it returned a normal completion. But when it has evaluated a statement, when it has evaluated the body of the if, it is actually returning something called just a completion and passing this statement completion in here. What that means is it might not be a normal completion now. For example, if your if body contains a throw error, right? Or if it contains a let's say if it is within a function, if it has a return statement. So in these cases, this is not going to be actually a normal completion, but it's basically going to return the same type of completion that you passed, that you sort of returned from the statement. So whatever your statement returns, it's going to sort of forward the same return value from the whole if statement. Okay, so this is basically how things like throw, break, or return values gets propagated. So if it got a return value, it's going to actually move it up to the higher layer. It's going to return it to the enclosing statement. Now we saw this thing called ToBoolean here. And the good part is, because it's a HTML document and because these are like nice enough people, these things are linked to the definition. So if I click on ToBoolean, it's going to actually take me to a section where ToBoolean is defined. We can just take a quick look at that to understand what happens, right? So we kind of know the answer, but hey, what happens when you try to convert a string to a boolean? Let's see. So I go to this ToBoolean section, and wow, this actually looks nice and easy to understand. It's like a nice little table which says that what is converted true, what is converted to false, right? So we are looking for a string, right? So I'm going to just search here. Okay, string, cool. If argument is empty string, okay, if its length is 0, then return false, otherwise return true, right? There we have our answer. If the string was empty, it's false. If not, it's true. Similarly, depending on your data type, you can basically just look it up here and see what it returns, right? Let's say if it is a boolean, it returns the same thing, because hey, we are trying to convert something to a boolean. If we get a boolean already, it's good enough, right? You can just return that. Okay. And the other thing I think which we saw is normal completion, right? Similar way, we can go to the part where completion records are defined. So normal completion basically says return a completion, if you notice this part, with type normal. So let's look at what completion is. And it says that completion is like some kind of a record, but again, records, if you sort of compare it to what you have in JavaScript, it's like an object, right? You have some keys and some values. Of course, these are not objects which are available to JavaScript. These are some internal values that they store, but it's the same idea. So it says that if the field name is type, if the key is sort of type, then it can be one of these things. So remember, we told that if the if returns a false, then it returns a normal completion. So normal completion is usually returned whenever our own statements or our own code doesn't return anything, or if it is not run at all. So mostly a lot of cases you will see a normal completion. That means that the user didn't want to break out of the statement or the evaluation himself. Other than that, we have break, continue, return, or throw. So as you might understand, if you use these statements, it's going to actually change the control flow. Okay. And similarly, it contains some value. So maybe if you're returning 1, 2, 3, this value will contain 1, 2, 3, right? And there is something called target. This is like not very important right now, but if you have a continue or a throw statement, if you remember, right, we don't actually use it nowadays, but your continue can have a label. You can say continue till this level. So that's what the target contains, but we don't really use it most of the time. We looked at completion record. Now let's look at 2 more examples, and that should be enough for our introduction. So let's look at how a block statement works and how it creates a block scope. So you know all these things, right? If you see a curly brace anywhere, that at least in our mental model creates a block scope. So how is a scope created? Because again, this is something you will see in a lot of other algorithms. It will be like a part of those things. So what I'll try to do here is, using the table of contents, I can navigate to this thing called block, right? We have reached the block. Again, I'll try to go to one of the runtime semantics, right? So if we go here, let's see. Okay, so it says block has 2 forms. It can be an empty curly braces, in which case it's not really interesting. It can just keep doing anything. But the other part which we use is a curly brace with something in there, right? So notice what it does initially. Okay, so it says that old env equal to execution context lexical environment. So it says running execution context. So execution context is like your call stack. Running execution context is the latest call stack. So this call stack contains a pointer called lexical environment. Okay, so whenever we say that find the closest block scope, so whenever we do let I, right, what is our mental model? We look for the closest block scope and then declare the variable there, right? So this is like a shortcut to the same thing. Your execution context contains a pointer called lexical environment, which directly points to your current block scope. Okay, so it's basically storing the current scope using a variable. Okay, notice what it does next. So now it is creating a new scope. So whenever you see a new declarative environment, So a declarative environment is used both for a function scope as well as a block scope. So it's creating a declarative environment by passing in the old env right here, if you can notice. So what that means is that this creates an environment whose parent is set to the old environment. So now I hope you can see where this is going, right? We effectively want to create a new environment, create a new scope, so to say. Now this new scope should point back to the parent scope. So that's what it is doing. It's still creating the new scope. Now remember, in the language, it has to create a scope and then set it as the current scope. These are two separate steps. Okay, so it can create a scope and still keep it around and later only set it as the current scope. Okay, cool. So we have this thing called block env, which is our new scope, but it is still not currently set, right? So now look at line number 4. It says that the same lexical environment pointer that we had earlier, okay, so point that pointer to the new block environment. So it's saying that stop pointing to the old environment. This is the new, latest block environment. So point the lexical environment to just this one. And what this thing usually does is that whenever you enter a block scope, it creates a new scope, stores the old environment as a reference, and when you are exiting the block scope, it will set back the lexical environment to the old scope. Okay, so whenever you enter, it points the pointer to a new thing. Whenever you exit, it points it back to the old thing. So if you see back at the line, last line, it just says set the lexical environment to old env, right? Whenever you are getting out of the scope, this is how it's sort of destroying the new scope. And that's all, right? So you will see this general structure. Whenever you sort of see that it's storing the old env, you will get the idea that okay, it's probably trying to create a new scope here, and when that scope is created, when it will try to exit, then it will set it back to the old value, right? So one thing to note here, in a lot of places you will see that whenever it's evaluating a statement, it has to it has to check if the statement returned a throw or an error, right? So if it returned a throw, it has to still do all the cleanup every time. Even if your code is exiting at line 5 of the algorithm and the algorithm is much bigger, it will still make sure that this lexical environment is pointed to the right old env, right? So this sort of like cleanup. Whenever your algorithm tries to exit, it will always make sure that the cleanup is happening somehow or other. So the last thing we want to look at is Object.assign. So this would give us an idea of how the public methods are defined. Okay, so let's look at the definition of Object.assign. So it says that Object.assign assigns some of the properties of sources to a target. So whatever is the own properties of sources, and if they are enumerable, then all those properties are also set on the target. So code wise, this is how it looks. So if you have a foo object, empty object, let's say, and if you do Object.assign foo and some other object on the right, so you can put multiple ones here. So now after this thing is done, then your foo is basically going to contain all the properties. So you can copy a lot of properties from different objects into a target object. That's how Object.assign works. Now let's look at like how it is defined. Okay, so the first thing it says is that convert target to a object. Okay, this is interesting. What it really means is that your target might or might not be an object, right? So what this technically means is, if we go back to our code, this thing in here could have also been a string. Okay, it could have been anything. It doesn't have to be an object. So that's why it's calling toObject on the target. Let's see what toObject does. And also notice one more thing. If you can see it here, it contains a question mark. Okay, so it looks somewhat like our ternary operator in JavaScript, but that's really not what it means. So a question mark before something like a toObject, what that really means is that toObject might return a abrupt completion in some cases. So abrupt completion means basically your toObject can throw some kind of a error in some cases. Okay, so it doesn't really change the meaning of toObject, but when you are reading this code, it gives you an idea that which all methods you are calling, which are safe and which might throw some kind of error. So we already know that toObject throws some kind of an error in some cases. So let's go into its definition. So if you go in here, that's the exact first thing you notice. In case of undefined and null, it's going to throw a type error, right? So again, if you go back to our code, so you can understand if this thing was undefined, now in all JavaScript engines, this is going to throw a type error, right? So you can be sure of that. So if you have basically gone through the code of Object.assign, you know that it can in some cases throw an error. So this is a level of details that you can learn or understand when you're going through the specification. These things might or might not be captured in other documents or even in the MDN documentation sometimes. So speaking of MDN documentation, you notice this, it calls toObject, right? It tries to convert everything to object. So we know how this is supposed to work. If it is an object, return the same thing. But if it is any of the primitive types, then create a box object which actually contains that value. Like for example, in case of Boolean, it creates a Boolean object whose Boolean data is set to the value true or false. So this is like what we usually call as a box object. So speaking of MDN, notice one thing. It takes target, does a toObject of target and stores it in a new variable. So that is the variable which will get returned in the end. What that means is that whatever target you have passed to Object.assign, right? If you expect this target to be modified, and if you expect that Object.assign returns the same thing as the target, that is not always true. So if your target, in some cases, right, if it is a primitive type, then the return value of Object.assign is different from the target that was passed in here, right? So this thing, I checked in the MDN documentation, they say that the target that was passed in gets always returned, right? And that's of course true in most of the actual use cases. But again, these are the things that if you really want to know in details, or if you want to see the edge cases, that's where the spec will really help you out. Okay, so back to the code. Now you have your modified target object called as to, and your sources is what is called a list of argument values, blah blah, basically like a number of objects, right? So what it is doing is it's going to go through each of the sources, convert that source to an object, right? Now you already know what toObject does, and from that object it's calling something called own property keys. So notice that we have no hyperlink here. Like I want to really go to what own property keys does, but I don't really have a link here. Okay, that's because to give you the direct answer, there can be multiple kinds of object. Okay, so what you normally use is called like a ordinary object, I think, but there can also be some special what is called exotic objects. So what this really means is that your own property keys has different kinds of definition depending on your type of object. So that's why it can't really hyperlink to one of them, because there are multiple implementations of this. So this is where I think just pretty much going in and command F command V, right, searching for it makes a lot more sense. Okay, so you will probably get a lot of entries, but if you know that where all things are usually used, right, you can sort of filter through it a little bit faster. Okay, so anyway, we all kind of know what getOnProperty does, is that if you have an object, it returns those keys which are defined on the same object, so it doesn't follow the prototype chain. So if it says that if description is not undefined, okay, and if description.enumerable is true, so this thing is called a property descriptor. So just like we saw in case of completion record, there is a different type of structure called property descriptor. Okay, and it's also accessible to, if you are doing object or define properties, you are basically sending object like property descriptor. So if it contains this enumerable which is true, right, then you basically take the value of that key, and on the to object, that is on the target object, you define the same key with the value from the source object. Okay, so for all the source objects, for all its own keys, if it is enumerable, then copy that same key name and the value to the target object. So that's what Object.assign is doing here. Okay, so the purpose wasn't really to explain it, because you already kind of know what it does, but I hope you got to see that there are cases when you don't find a hyperlink directly, you have to search for things because there are like multiple implementations. Then the fact that object actually has multiple types, so you have normal objects and then exotic objects. Again, these are like not two types, you can basically have like subtypes within that. And the last thing is that hopefully you get to see that there are some cases where it is much more useful to go through the spec directly instead of looking for like multiple blog posts or multiple documentation to see what a method can or cannot do. So I hope like this was at least a little bit interesting, and you get to see the benefits of going through it directly, right? So the only thing I would really ask you to do is give it a shot, right? Now go through some method that you already know. Don't go through something really complex. Okay, just go through array.push, see what it does. Okay, now you'll probably understand it initially at a very high level, very abstract level. Okay, so you will understand the part where it's actually pushing something into array, but maybe you will not understand the preparation code and the exit code, right? So again, those are the things that you will understand better when you try to do it more and more, right? But at least when you start getting an overall abstract idea of the things, that's when I think it will feel more interesting, and you'll start to go to these connected things and see what it really says there. Okay, so yeah, that's it. Hopefully you learned something. Hopefully it wasn't too boring, and see you next time.